Hello everyone, I hope everyone is doing good. So in today's video, this video is going to be the continuation of the previous video. So in the previous video, we have talked about the LangGraph. We have seen how we can create a graph. Now how it is going to be useful in creating a GenAI application. Mostly we are creating an agent, which is calling an LLM for some of the work for the task. And LangGraph is the framework which helps in doing all this stuff. Since last few days, my mic was not working. I tried to repair it, but it's still not working. So there was some delay in the second part of this LangGraph video. I'm using this mic. I hope the sound will be good. At least it should be more understandable and audible. Anyway, so in this video, we'll look more into the LangGraph. We'll look into the ReAct application, ReAct. It stands for reasoning and acting. So I was telling about the ReAct, reasoning and acting. So this is a kind of application in the Agentic AI where agent will do the reasoning on your prompt. Like if you have given some task to the agent, so agent will think over the task and then decide that which tool to use. Like if there are multiple tools, so like in our example, we are going to create a tool for addition, subtraction, or there will be some different kind of information. Like in the tool, you can add like you can the agent can go into some different website and do some stuff. So a multiple tools actionable items you can add in the tool, and agent will do the reasoning. It will try to think over like which tool it has to use for the problem statement. It will go to the tool node, use that tool, and that information is again returned back to the agent. Then agent will again use the LLM and try to formulate the answer for you, and then the graph will end. So you can see there are basically four graph. One is the start and end is like in all the lang graph you have to have the two node. One is the start and the other is the end. The other is the tools and the agent, and you can see there is a arrow between tools and agent and tool. This loop should be there because agent will talk to the tool, will do some task, then tool will reply back to the agent with some answer. For example, I'm asking the agent to add two numbers. So agent will ask the tool, look into multiple tools in the tool node. If there is some tool which does the addition, so then addition of the number is returned back to the agent, and then agent will formulate the answer. Okay, so you will see now like how that formulating of answer is helpful. Why don't we can directly go and use the tool and get the answer, because LLM will add few of its more information on the top of the answer. So this is what we are going to do in this section, and we'll go through the code how we can write an application on top of that. We'll also look into the few more imports which we have done in this particular videos. We'll see now. So guys, if you're new to this channel and you like the videos, you want to learn more about the data engineering, want to discuss more about the data engineering skills, and also the GenAI skill, then please subscribe to our channel and please help me to share this video across all the groups, all the people who wants to be in the data engineering field, want to accelerate, want to get into the GenAI. Okay, so we'll go to the code section now. So this is a simple code. So there are multiple imports which has been done. I already have copied the code from somewhere, and I'll try to explain it here so that it will be fast. Like you will learn about how to write this code. So you have already learned like how to write a lang graph code, how to create the node, how to create the edges. Here you will understand more into it. So I would suggest like go to my previous video, go into the LangGraph basics, and then that will create a very good base for you to understand this particular logic. So we are importing sequence type dictionary, which we have seen last time in the last video. What is type disk? Like in Python, we generally don't describe the data type of any variable, but with the help of type dictionary, we can tell the Python that this variable is of which types. Like for example, here I'm just creating a variable a, so it is of int type. So I'm just giving the data type for this variable. So this is the type dictionary. Annotated is the new one in which we give more information, a kind of metadata information to the variable. We'll look now. So I have searched annotated in this in the Google. So you can see, as I have told, with the annotated, you can add metadata information with the variable type. For example, I'll just look for one very small example. Let me see. Okay, I'll click on this. For example, you have created a variable called name. So if I'm not going to use annotated, so you can directly write the name. or and you're using a type dict, then you can write the string type. But with the annotated, you can write the variable. We can first parameter in the annotated is the data type. So string is the data type for the name, and what you want to give the information in extra metadata information with this variable. Like the first letter is capital, so the first letter has to be capital. So it doesn't mean that when you write the first letter is capital, then this rule will be applied to this name variable. That is not going to happen. For that, you have to write a logic, or you can write a logic here itself, some regex logic, which will check that your variable first letter is capital or not. Okay. So that you can do here. Like for example, it has done like here. So here it is defined here. So define read underscore items q. Annotated is this is the queue is of string type, and what I want to apply into this, what extra information I want to put on this variable is query max length. So max length of this queue should be 50. So here I have just given an information, and here I have applied something on this variable. So this is annotated. So we'll look into it now. So here you see I have added a message variable, which is an annotated type. I have added a sequence. Its data type is a sequence. I'll show like what is sequence. And then what I want to do in this variable is add message. We'll see what is add message. So we understood what is annotated. We already know that dictionary, type dictionary. Sequence means one by one. You are adding multiple things into a variable. That is called sequence. For example, when you are doing a chat with the chat GPT, you are writing, hi, how are you? Then there are few chats, and again you will write, okay, I'm from India. So the new chat is not going to replace your previous chat. It will be adding to the previous items. So it will create a long string of chat with the help of sequence. Okay. Then there are set of messages which I have imported. The first is the base message, then tool message, and then system message. So system message is very simple. System message is the message which you want, which you give to the LLM. Like when you write a prompt to the LLM, like you just do something, do some task. So that is the system message. Tool message is very important. Tool message means, I'll show you. So tool message comes here in this picture when the tool reply back to the agent. So that is a tool message. See, agent will do some reasoning, then give some instruction to the tools. So tools will do some work, and then tool will reply back to agent. So once this tool reply back to agent, that is a message. So that message itself is the tool message. So that kind of message we call it a tool message. And the last is the base message. Base message is the parent of all the messages. It's a hierarchy wise. It's a base message. It doesn't mean much into the context, but it's a bigger hierarchy of a message in which there is a tool message, there is a system message, there is a human message. These all things come into it. We already know chat API, chat open API, which we are going to use. We will import that. We are importing tools to create the tools. You can see here we are creating the tools. So tools is important to create the tools. Add message is a kind of thing which update your state. For example, in the previous, let's just understand it in a simple way. So you have a state of your graph. State, for example, state means a particular position, a particular information. So information is I'm traveling to Delhi. This is the information, what the state. Now I will eat pani puri in Delhi. So that is a different information in that state. I want to add these two information in a single state. So now my single state should be I am going to Delhi. I will eat pani puri. So it becomes a single state. If you don't use add message, then what will happen? Your first state will be I'm going to Delhi. The second state will replace your first state and add the state value as I am going to eat pani puri. So to add all the sequence of the message to create a single context of the whole summary or a whole paragraph, for that we use add message. Now, so as we know, like we load the environment variable. So in our environment variable, we have used the API key. So that is in that. Now we have, I think in the last video, I have shown how to create a API key, how much money you should spend in the initial phase. If you have still doubt in this, just put your comment in the video. I will again create a short video on that. So you create a class of type dictionary in which the message is there. Message is going to get all the sequence of the message when you interact with the agent, and that will also update the state. We'll see how it is going to update the state. we have created three tools. First is add, a simple add. Like when you would have used any other language, there is like overloading, function overloading things, or multiple functions you create for multiple work. So it is add message, add tool. This is subtract tool. This is multiply tool. So I have created all these three tools, and these three tools I'm telling the this program that the tools which we have imported, that I have these three tools. Now your agent need to understand which tool to apply for which scenario. Okay, so I have these three tools: add, subtract, multiply. If you write addition to the agent, your agent should be intelligent enough to understand that addition means add. Okay, and then it will redirect to the add tools. So model which we are going to use is GPT-4o. Okay. Now we are adding a system message. Like, you are my AI assistant. Please answer my queries to the best of your ability. Okay. This is just for writing the system message. What is system message? The message which we give to the, here we have imported here. You see system message, the message which we give to the agent, which we give to the LLM. Response, system message plus state message will comes. I'll just show you, this message will come as a state, and then it will return the messages. Now this message is the combination of all the add messages. So here the state will get updated. It will not get replaced by the new value of the state. The state will get updated every time when it is called. Now we'll come to this. What is this? Okay. It is like, do we have to continue or not? Like, I have just shown you this one. This agent is going to call the tool. The tool is going to return back the answer to agent. So this loop should end at some time. So if there is one condition which will add. So this is called conditional edges, which I think we had discussed in the previous video. So this condition edges will we are going to create, and then in that condition, in there we will write the logic for that condition, like for on which condition the this loop should break. So for this condition we are creating a conditional edges. See, edges is creating in the below part, but this the function which we are defining here, I'm just telling it as an edges, but this is not an exact edges. When we convert this into edge by adding the node, at that time it becomes the edge, but for the understanding I'm saying it as a edges. So message equal to state messages. So message is getting updated. Okay, fine. The last message equal to message minus one if there is no message. If not last message, tool calls. If there is no tool call for the last message, like if all the work has been completed and there is no messages left there to tools calls, because agent can call the tools multiple times if you have given multiple instruction, like add two numbers, then multiply with some numbers, subtract with some numbers. So your agent will divide this with the help of LLM. Your agent will divide this information into small chunks and small instructions. That instruction will be passed to the tools node. So it will see in the queue that if there is no message, minus one means if there is no messages, that means there is no tool call, so return end. And if there is some message, then return continue. In the end, it will go to the end node. In the continue, it will again go into the loop of that agent and the two. So we are defining the state graph here. We are adding the node. Our agent, we are giving the name our agent, and the model call is the first one which we are creating. Then tool node, we are creating a tool node which is tools equal to tools. This is tool node, and we are adding it. Add node is the tool node. Then entry point, the first node. Like I'll show you here. This is our entry point. Entry point means it is connected to the start node. So we are calling this as an entry point, and this is another node, and this is our exit point. So where it goes, entry point. Set entry point is our agent. What is our agent? Our agent is model call. What is model call? Model call is this logic, the first one. Then we have added one node as a okay, here we set entry we have done. Then add conditional edges. What is for that conditional edges? So it again, this is this one. These two we have to add for the conditional edges. So in which condition it should work. Our agent, okay, this one should continue equal to tools and equal to end. If the output return is continue, then go to the tool node. So what is tools? Tools is the tool node. Okay. If the output of this is end, that means go to the end node. I hope you are able to understand it. You can go through it again, you will understand it in a better way. So I'm defining here return type. If I have a return of end, go to the end node. If I have a return of continue, go to the continue node. So in our case, end is end, that is fine, but continue is the tool node itself, which we have added it here, added tools. Okay, then we have to add tools to our agent. Okay, that's for creating a graph. So compile it. Okay, once it is compiled, your graph is compiled, you can run this separately so that you can check that your graph is compiled properly. And then I am going to give an input to it. So input is I'm creating a function where I'll be passing the information as an input. So input is user is giving the input with the form of a messages, add 4 plus 6 and then multiply the result by 6. So now see here, there are two information. First is addition and there is a multiplication. In this I have given the plus sign. That means what agent will do, agent will divide this into two parts. One is the addition and other is the multiplication. So first this addition will go to the tool will return back the answer. Agent will have that answer within himself. Then that summation will be again passed as a second instruction to the tool that multiply the result with 6. Then again the tool will give back the call to the agent like this is the information, and then agent with the help of LLM will construct the answer out of it in a proper way and will present it. Now here two times your agent is going to call the tool. First is addition and second is the one multiplication. So if you add multiple more instruction in it, so there will be multiple more that loop will be running, which we have seen that edge condition and that loop. So we'll run this program. So we'll run this program. Okay, what is the name? Okay, there's some error. Let me look into it. So the error which we can see here is the function must be docstring if definition is not provided. Okay, so when you created this, so I've added first going through the error. So I've added the docstring. So docstring is basically giving the description to your function, your module, or the variable also. So when we have created the function, so we have not described it. And docstring follows. It's not a comment. It follows the structure of the Python. So it should be written into a proper fashion how we write a Python program. Let's see it. Let me save this one if it works. Okay. So now you can see here. Okay. So the answer is first adding 4 and 6 gives 10 and then multiplying the result by 6 gives 60. So this kind of answer, the formulation of answer can be done with the help of LLM. So if the agent is not getting the output of the tool and formulating the answer, then your answer should be directly 60, but it is writing in a proper way. So if you have a complex scenario, then this is will be very much good in the explaining something. If you write something, ask any question to LLM. So apart from if you do go to ChatGPT, you ask any of the scenario, the ChatGPT will give you the answer. Plus, it will also explain it. The same thing it is doing now. Okay. So how many tools it is calling? It is calling add tool. Tool calls is add tool. The second is multiply. Okay, there is no subtraction, so the another is multiplication. So that means two times your agent has called the tool and it has identified that which tool it has to call. So your program logic should be written in such a way, your agent should be created, your agent graph should be created in so intelligent way that if you write a different kind of prompt also, then also it should understand that which tool it has to use. Now here again you can include MCP in the later advanced stage. We'll see that how we can include MCP in the same thing. We'll have a set of tools and where our agent will call. Now multiple tools has come up with the MCP connector. You can connect to like cloud. You connect to your VS Code also to the MCP server, and then your agent is using the same reasoning to decide that in which tool it has to go and call that tool or work on that tool. So your agent is just calling the tool, the tool does the work and it gives the result to the agent. And then agent tries its intelligence with the help of LLM and give you this kind of answer. Fine. I hope you're able to understand why what is this React, what is this tools. Because if you go through some of the vlog of the MCP server, why we need MCP server, how this MCP server works, I've already explained in one of the video in very high level. So then you will understand that how this React, the reasoning of the agent is getting useful in nowadays in the advanced GenAI pipeline also. So I'll just suggest you to go through this, try to understand this thing. This is very simplified example. I've copied from some of the GitHub repository, and then you will get the same kind of information in multiple places, multiple vlogs. Try to create a fundamental of LangGraph. That is more important. Try to understand how to create the node, when to create the node, how to get the information, the state. State is very important. If I'm not going to use state in a proper way, if I'm not going to use add messages, that means combining all the state, updating all the state, then my information will be not like this. The LLM will lose the context, or it will give you the answer just something different. It will lose the context because the state value is changing. I'm just updating the state value. I'm not replacing it with the new state value. So this is important. Understanding the state is important. Understanding different kind of edges, conditional edges is important. Understanding different type of nodes. Try to create some scenarios. Try to think of some complex. You can Google it. You can get complex scenario and try to work on the line graph. And for the API key, if you have any doubt, please post in the comment. I'll create a short video, 5 minutes video on how to create an API key and how you can do it at small cost. Okay, till then, we'll meet in the next video with the next topic. I'll try to come up with something different in GenAI, or I have something more in mind regarding Snowflake. Like we have discussed Cortex AI for the Snowflake, but there are more into Cortex AI which has come into Snowflake product. So we'll discuss more into it in the next video. Okay, if you have any doubt, please post the comment. Try to connect me through LinkedIn, or you can directly mail me. Till then, thank you and happy learning.